Hello students, in this session of our revision of metallurgy, we are going to discuss extraction of aluminium. So aluminium ore is bauxite, whose chemical formula is Al2O3.NH2O. Bauxite contains 30% to 70% of Al2O3 and remaining part is gangue. The impurities are silica, which is SiO2, ferric oxide, Fe2O3, and titanium oxide, that is TiO2. So extraction of aluminium takes place in major two steps, that is concentration of bauxite ore and electrolytic reduction of alumina. So concentration of bauxite ore can be carried out by means of either of two methods, that is Bayer's method or Hall's method. In both the methods, separation of these impurities is done by leaching process. The concentrated alumina is obtained by calcination. Once we obtain alumina, it is electrolytically reduced to get aluminium. Now we discuss each process in detail. So Bayer's method. Leaching of bauxite. So the bauxite ore is first ground in a ball mill. Then it is leached by heating with concentrated solution of caustic soda, that is NaOH, at 140 degree to 150 degrees Celsius under high pressure for 2 to 8 hours in a digester. Aluminium oxide, being amphoteric in nature, it reacts with the aqueous solution of sodium hydroxide to form water-soluble sodium aluminate. The chemical equation for the reaction is Al2O3.2H2O plus 2NaOH, giving us twice NaAlO2 plus thrice H2O. The iron oxide in the gangue does not dissolve in aqueous sodium hydroxide and is separated by filtration. However, silica in the gangue dissolves in aqueous sodium hydroxide to form water-soluble sodium silicate. Aqueous sodium aluminate is diluted by putting in water and is cooled to 50 degrees Celsius. This results in precipitation of aluminium hydroxide. The chemical reaction or equation for the same is NaAlO2 plus twice H2O, giving us NaOH plus AlOH3 OH thrice. The next method is Hall's method. Again, in this case, leaching of bauxite is done for concentration of ore. So again, the ore is powdered, then it is leached by heating with aqueous sodium carbonate in the digester to form water-soluble sodium aluminate. The insoluble impurities are filtered out. The filtrate is warmed and neutralized by passing carbon dioxide gas through it. This results in the precipitation of aluminium hydroxide. The balanced chemical equations for these reactions are Al2O3.2H2O plus Na2CO3, giving us twice NaAlO2 plus CO2 plus H2O, then twice NaAlO2, which is sodium aluminate. So twice NaAlO2 plus thrice H2O plus CO2 gives us twice AlOH thrice plus Na2CO3. So by means of either of these two methods, concentration of ore is done. So once concentration of ore is done, from AlOH thrice, we need to obtain alumina. The precipitate of AlOH thrice is obtained in both Bayer's and Hall's processes. It is filtered, washed, and dried. It is then calcinated by heating at 1000 degrees Celsius to obtain alumina. So the balanced chemical equation for the same is twice AlOH thrice, giving us Al2O3 plus 3H2O. Thus, alumina, that is Al2O3, is obtained. Now, alumina is reduced later to obtain aluminium. Now, here we discuss electrolytic reduction of alumina. The setup is In this method, electrolysis of molten mixture of alumina, whose melting point is greater than 2000 degrees Celsius, is done in a steel tank. The tank has a graphite lining on the inner side. The lining does the work of a cathode. A set of graphite rods dipped in the molten electrolyte works as anode. Cryolite, which is Na3AlF6, and fluorspar, that is CaF2, are added to the mixture to lower its melting point up to 1000 degrees Celsius. So this is the important function served by cryolite and fluorspar. Once the setup is ready, the working for electrolytic reduction of alumina is, on passing current, aluminium is deposited on the cathode. Molten aluminium, being heavier than the electrolyte, is collected at the bottom of the tank. It is taken out from there from time to time. Oxygen gas is liberated at the anode. So we discuss the anode and cathode reactions here. So at anode, we have the oxygen ion, which is negatively charged, that is O2 minus, giving us O2, which is O2 gas, and 4 electrons. Whereas as at cathode, we have the positively charged aluminium ion, which is Al3+, plus it receives 3 electrons, thereby giving aluminium metal. So at cathode, reduction takes place. At anode, oxidation takes place. The liberated oxygen reacts with the anodes to form carbon dioxide gas. The anodes have to be changed from time to time as they get oxidized during the electrolysis of alumina. With this, we come to the end of this part of revision, which was extraction of aluminium. For the remaining part of the chapter, we'll meet in the next video. Till then, bye-bye.